Proxima Centauri, the closest star to our planetary gathering, has for quite a while been a subject of interest for cosmologists. This little red diminutive person found in 1915 by Scottish space master Robert Innes is fundamental for the Alpha Centauri structure, which in like manner consolidates Alpha Centauri and B. No matter what its area 4.24 light-years away, it stays imperceptible to the unaided eye because of its generally low splendor. At any rate, Proxima Centauri holds enormous legitimate regard, especially as the host star of Proxima be an exoplanet that circles inside the star's valid zone. Red smaller people like Proxima Centauri are more modest, cooler, and essentially longer resided than stars like our Sun. Their low gleam makes them trying to see, yet it likewise suggests their reasonable zones are a lot nearer to the star. For Proxima Centauri, this implies an orbital distance of 0.05 galactic units, a straightforward part of the distance among Earth and the Sun. This closeness opens Proxima b to serious heavenly action, including successive sun-powered flares and elevated degrees of radiation, making its air unmistakably not the same as Earth's. The revelation of Proxima b was an astounding achievement in exoplanet research, utilizing the outspread speed technique. Stargazers distinguished unobtrusive wobbles in Proxima Centauri position brought about by the gravitational draw of a circling planet. These wobbles permitted specialists to quantify the planet's mass and orbital period. In 2016, the European Southern Observatory officially affirmed the presence of Proxima b, denoting a forward leap in the quest for possibly decent universes past our planetary gathering. While ground-based perceptions have given huge experiences into Proxima b, they accompany gigantic limitations. Air twisting and light obstruction forestall Earth-based telescopes from catching definite data about the planet's surface or air. The greater part of the information we have, like its mass separation from the star and orbital qualities, relies upon roundabout estimations to uncover further experiences into Proxima's current circumstance and its true capacity for life. Further developed observational devices like the James Webb Space Telescope JWST are basic. Proxima Centauri's job as a passage to understanding exoplanetary frameworks can't be misrepresented as the closest star framework to Earth. It offers a one-of-a-kind chance to read up the circumstances vital for life. Proxima b specifically addresses a tempting opportunity, a rough Earth-sized planet with the possibility to hold on to water and maybe life anyway. The difficulties presented by its unforgiving environment make it a perplexing riddle for analysts to settle. The James Webb Space Telescope JWST isn't simply one more instrument in that frame of mind of cosmology, it is an unrest intended to succeed the Hubble Space Telescope. JWST was imagined to address the restrictions of its ancestor and push the limits of human information. While Hubble has given huge bits of knowledge into the universe, its abilities are restricted by its shine on apparent and bright light. JWST then again is work to notice the universe in infrared frequencies, permitting it to glance through immense residue mists and uncover peculiarities undetectable to Hubble. One of the key plan elements of JWST is its essential mirror, which traverses a noteworthy 6.5 m in width, over 2 times the size of Hubble's mirror. This bigger mirror empowers JWST to accumulate substantially more light, making it fit for noticing staggeringly weak and far-off objects covered with a slender layer of gold. To improve its infrared reflectivity, the mirror is made out of 18 hexagonal portions that cooperate to shape a profoundly delicate observational stage. Another historic improvement is JWST layer sunshield, which keeps the telly's extensions instruments at a steady temperature of about 233 degrees Celsius. This ultra-cold climate is pivotal for identifying faint infrared signs without impedance from the telescope's own intensity, dissimilar to Hubble, which circles Earth. JWS works from the second range point L2, a steady situation around 1.5 million kilometers from our planet. This area limits impedance from Earth's intensity and light, permitting JWST to keep up with persistent perceptions. The telescope can concentrate on everything from the earliest worlds to the climates of exoplanets like Proxima b. Its capacity to recognize infrared light is particularly significant as it permits cosmologists to shine on redshifted peculiarities, protests whose light has been extended to longer frequencies as the universe grows. JWST capacities reach out a long ways past straightforward perception. It is intended to respond to probably the most key inquiries in science, including the starting points of universes, the arrangement of stars, and the circumstances that could uphold life on different planets. With its best-in-class instruments, including the close-to-infrared camera NCAM, the mid-infrared instrument MIRI, and the close-to-infrared spectrograph NSPEC, JWST isn't a telescope, it is a time machine, a lab, and a demonstration of human resourcefulness. Proxima b has enraptured researchers and the public, the same as a potential second Earth arranged inside its star's livable zone. The planet has the right circumstances to possibly uphold fluid water, a critical component for life as far as we might be concerned. With a mass generally 1.17 times that of Earth, Proxima b is logical. A rough planet comparative in synthesis to our own. Its vicinity to Earth, a little more than 4 light-years away, makes it an ideal objective for reading up the potential for life past our planetary group. Anyway, Proxima b is a long way from an ideal twin of Earth. One of its most striking elements is that it is flawlessly locked, meaning one side of the planet is in unending daylight while the other is in everlasting obscurity. This establishes an extraordinary climate with outrageous temperature. Contrasts between the two halves of the globe. The district where day meets night, known as the Eliminator Line, might offer a tight exceptional zone with conditions sufficiently gentle to help life. The difficulties presented by Proxima Honeybee's environment are huge. Its host star, Proxima Centauri, is a red smaller person known for its extreme sun-powered flares, which can emanate eruptions of X-beams and bright radiation. These flares could strip away the planet's air after some time, presenting its surface to the brutality of room. On the off chance that Proxima holds any air, it would probably require areas of strength for a field to shield it from radiation. Without such security, the surface and air would be threatening to life as far as we might be concerned. In spite of these difficulties, researchers stay confident about the potential for life on Proxima b. The planet's area inside the tenable zone proposes that fluid water could exist either on its surface or in subsurface supplies. Life might adjust to the unforgiving circumstances similar as extreme documents on Earth. Organic entities that flourish in outrageous conditions, for example, remote ocean aqueous vents or high radiation zones. These transformations could incorporate radiation opposition, subsurface territories, or remarkable biochemical cycles. The quest for life on Proxima b is something other than a logical try. It is a mission to respond to one of humankind's most established questions. Are we alone in the universe? Proxima b presents a tempting chance, a rough Earth-like world that could hold on to the circumstances fundamental for life. As our innovation progresses, so too does our capacity to investigate this entrancing planet and uncover its mysteries. While Proxima b presents enticing possibilities, its environment is significantly impacted by the nature of its host star, Proxima Centauri. Unlike our Sun, Proxima Centauri is a red dwarf, smaller, cooler, and significantly less luminous. Its reduced size and temperature imply that its habitable zone is much closer, pulling Proxima b into an orbit just 0.05 astronomical units from the star, about 20 times closer than Earth is to the Sun. This proximity creates a unique set of challenges for the planet and any potential life it might harbor. One significant issue is Proxima Centauri's stellar activity, particularly its intense and frequent solar flares. These flares are sudden, powerful bursts of energy that release high doses of X-rays and ultraviolet radiation. Such events are far more common and energetic in red dwarfs than in stars like our Sun. For Proxima b, this means a constant barrage of high-energy particles, which could strip away the planet's atmosphere over time. Without a protective magnetic field, any atmosphere on Proxima b would be vulnerable to erosion, exposing its surface to harsh radiation. Even if Proxima b retains some of its atmosphere, the radiation from Proxima Centauri presents serious challenges for life. High levels of ultraviolet radiation can break molecular bonds, preventing the formation of complex organic compounds. This would severely limit the potential for life to develop or sustain itself on the planet's surface. On Earth, organisms like Deinococcus radiodurans have evolved mechanisms to repair DNA damage caused by radiation, suggesting that life on Proxima b could similarly adapt. However, the level of radiation resistance required would be extreme, potentially requiring entirely new biochemistries. Interestingly, Proxima b's tidally locked nature might offer some protection. While one side of the planet faces constant radiation from Proxima Centauri, the planet's dark side could act as a refuge. Subsurface regions or deep caves could shield potential life forms from the worst of the radiation. Furthermore, if Proxima b has subsurface oceans, they could provide a stable radiation-free environment where microbial life could thrive, much like ecosystems around hydrothermal vents on Earth. Despite these challenges, scientists remain optimistic that Proxima b's unique environment offers a valuable opportunity to study the resilience of life. By understanding how organisms could survive or even thrive under such conditions, researchers can expand their knowledge of what makes a planet habitable. Proxima b isn't just a potential home for life. It is a cosmic laboratory for testing the limits of life itself. The planet's proximity to Earth and its location within the habitable zone of its star make it an ideal candidate for further study. With new telescopes and instruments, researchers will continue to monitor Proxima b for signs of habitability and life. However, the road ahead is filled with challenges. Proxima Centauri offers a fascinating glimpse into the possibilities of life beyond Earth, reminding us that our quest for knowledge and the search for life on other planets is only just beginning. The search for life beyond Earth continues, and the exploration of exoplanets like Proxima b plays a critical role in broadening our understanding of what conditions are necessary for life to exist. One of the key factors that makes Proxima b so intriguing is its relatively Earth-like size and composition, which makes it an excellent candidate for studying the potential habitability of planets outside our solar system. Scientists are particularly focused on finding planets with similar characteristics to Earth, as they offer the most promising conditions for the development of life. To further explore the possibility of life on Proxima b, astronomers are using various state-of-the-art techniques to analyze the planet's atmospheric composition and environmental conditions. One of the most promising methods is the study of exoplanet atmospheres through transmission spectroscopy. This technique involves observing how light from a star passes through an exoplanet's atmosphere during a transit, revealing the chemical makeup of the atmosphere. By analyzing the absorption lines in the light spectrum, scientists can detect the presence of gases like oxygen, methane, and carbon dioxide, which are often associated with life on Earth. Detecting such gases on Proxima b could provide strong evidence that the planet could support biological processes. Moreover, researchers are investigating the possibility of microbial life beneath the surface of Proxima b. The idea of subsurface life has gained momentum in recent years, especially with the discovery of extremophiles on Earth, organisms that thrive in environments once thought to be uninhabitable, such as deep-sea vents or acidic lakes. Subsurface oceans or springs could provide a stable and sheltered environment, protecting life from the harsh radiation and solar flares that bombard the planet's surface. If Proxima b has a liquid water supply beneath its surface, it could increase the chances of finding microbial life that has adapted to extreme conditions, much like Earth's deep ocean organisms. In addition to searching for life, Proxima b also offers a remarkable opportunity to learn more about the broader processes that govern planetary systems. The planet's location within the habitable zone of its star provides a unique chance to study the interactions between a planet and its host star, as well as how these interactions influence a planet's ability to support life. For example, the frequent solar flares produced by Proxima Centauri could play a crucial role in shaping the atmospheric conditions of Proxima b. These flares could affect the planet's atmospheric chemistry and even its magnetic field, all of which are important factors in determining whether the planet could support life. While the study of Proxima b is still in its early stages, advances in observational technology, such as the James Webb Space Telescope, are providing scientists with new tools to explore the mysteries of this exoplanet. JWST's infrared capabilities will allow for more detailed analyses of the planet's atmosphere, surface, and potential signs of habitability. As our understanding of exoplanets continues to evolve, Proxima b will remain at the forefront of efforts to answer one of the most profound questions in science. Is there life beyond Earth? Ultimately, the exploration of Proxima b isn't just about finding extraterrestrial life, but also about understanding